Hey there! From ChatGPT to Elon Musk's Tesla, artificial intelligence is powering a new wave of groundbreaking innovations. In this video, we will be showcasing you our latest project that uses artificial intelligence, nav-IRIS. The objective of our project is to build a robotic car that uses machine learning and vision detection so it can recognize traffic signs and respond accordingly. nav-IRIS is a fusion of cutting-edge technologies that include teachable machine, Arduino Uno, and ESP32 Cam. These technologies bridges the gap between artificial intelligence and the physical world. Together, they create a system that can recognize signs and symbols, interpret their meaning, and take physical actions based on that interpretation. Firstly, for motion control, we have the Arduino Uno board, a microcontroller that can be programmed to interact with the physical world. In nav-IRIS, Arduino is used to take physical actions based on the interpretations provided by the teachable machine. Secondly, we have machine learning. We have used teachable machine, which is a web-based platform that will be used to train our AI model for image recognition of different traffic signs and symbols, and train the model to identify them. Once trained, the model can be exported for nav-IRIS. Lastly, we have the ESP32 Cam microcontroller with onboard camera. It is an ideal solution for IoT applications and prototype constructions. In nav-IRIS, ESP32 Cam plays a vital role of detecting signs using its onboard camera, comparing them against the teachable machine, and interprets the results to the Arduino board. Its live stream will be accessible via any web browser. Let's look into the connections and workings of nav-IRIS. This is the ESP32 Cam onboard camera. We have used two pins, one for power and one for ground. The ESP32 Cam TX pin is connected to the Arduino's pin 11. In the Arduino Uno code, we have used serial programming to receive signals from the ESP32 Cam. The remaining pins are for the motors of the nav-IRIS. So when we turn on the power, the ESP32 Cam detects for traffic signs. As soon as it detects a traffic sign, it compares the image received with the teachable machine AI model. Once the AI model confirms the match, the ESP32 Cam sends a signal to the Arduino Uno using serial communication. Upon receiving the signal by the Arduino, it is compared with a set of conditions. The vehicle then responds by moving the robotic car. I hope you enjoyed the video as much as we enjoyed making it. Goodbye, and I'll see you in the next one.